Hey guys, so this is our first video for the unit. We've been talking about quadratics and just seen them a lot in transformations when we have stretched and shrunk and reflected and translated graphs. And that was a nice intro to this unit, but now we're ready to get into our learning targets. So this first two learning targets they go together, but I'm going to do this in a two-part video. So today you're watching part one, and then you'll be assigned part two later in the unit. So learning target one is identify the features revealed given a quadratic equation in various forms. Okay, so we'll talk about some of those features, and then learning target two is justify the conversion between different forms of quadratics. And so that'll be more part two of this, is getting into the different forms of quadratics. First, let's define a quadratic function. It's any function in the family of y equals x squared. That's going to be called our parent function. So maybe you want to talk about that. This is our parent function. And then a parabola is the shape of a quadratic. And so I'd like you to draw a parabola. Will either open up and kind of look like this. Either way, it's going to look like a U shape. So it will either open up or it will open downward. Like this. Okay, we'll see both of those. Those are both quadratics. We call them a parabola. Similar to a linear equation has a line, a quadratic equation has a parabola. Okay, and then some key features of a parabola. So let's say I have a parabola here. Let's draw an x and y axis. And then we're going to talk about some key features. So here's my parabola. This is a quadratic function. We won't really worry about the equation for this function right now. We're going to talk about some different points on it. The vertex of a parabola is where it changes direction. It's either the maximum point or the minimum point. In this case, the vertex would be the minimum point. It's the lowest point on the parabola. If our parabola opened downward, then the vertex would be the maximum point on the parabola. The roots, or the zeros, is where the parabola crosses the x-axis, or where y is 0. So here and here are going to be our roots. We also call those the zeros because that's when y is 0, what is x? Very similar to like the y-intercept of a linear line. These are really important. These 3 points are probably the most important points on a parabola. The direction of a parabola is just if it opens up, like this one down here does, or opens down, say like this one does. And then the scale factor is the amount that the parabola has stretched or shrunk. Okay, it's what it's multiplied by. It's going to end up being its leading coefficient. So if you have a scale factor of 2, it's going to be stretched up more, or shrunk down if we have a scale factor of a half. And we'll take a look at some of those. That will make more sense as we go on and talk about this example here. So get down those notes, and we'll move on to the example. We're asked to find the vertex, the zeros, and the direction and the scale factor of the parabola below. So we've got some nice zeros here. It looks like our zeros are 4 and 6. So I'm going to start with those. All right, our zeros are 4 and 6, or we could write that as the coordinate 4, 0, and 6, 0. That's where our parabola crosses the x-axis. So when y is 0, x is going to be 4, and it will also be 6. Our vertex is down here at 5, -2. Our direction is upwards. This parabola opens up. And then let's talk about our scale factor. Scale factor is you have to do some comparing to an original parabola, to our parent function. So we don't know the equation of this function. We'll learn how to do that in a while. But let's talk about y equals x squared. That's our parent function. What would that look like on here? That would have a point 0 squared is 0, 1 squared is 1, 2 squared is 4, and then 3 squared won't be on here. So our parent function would look something like that, okay? And then have the same thing on the other side. So let's compare these two functions and see what our scale factor is if we change it all in this. So if I look at a change as I go over 1 on the x, on my parent function I also go up 1. So a change in x of 1 resulted in a change of y of 1. Okay? If I go over 2 from my vertex, then it looks like I go up 4 because 2 squared is 4. So an x squared, or an x change of 2 meant a y change of 4. And we can look and say if we go up 3 or over 3, we would go up to 9. So we can even go a little step further if we need to, and say a change in 3 is going to be a change in 9. And then let's compare that to this parabola, our parabola here in this example. So a change in 1 of this parabola, an x change of 1, actually results in a y change of 2. A change in 2 of x results in a y change. Let's see if we can find our next nice point. Looks like here's my next nice point. So this is a change of 8. If we look on the y-axis, that's a change of 8. And if we change 3, we can't really see my next nice point, so we won't do that. But let's talk about the difference between these numbers and these numbers. In our parent function, a change of 1 in x meant a change of 1 in y. A change of 2 in x meant a change of 4 in y. Here, a change of 1 in x meant a change of 2 in y, and a change of 2 increased to a change of 4. So our scale factor here is doubling, okay? Our changes, our increase is doubling. So we have stretched this parabola by 2. So our scale factor is going to be 2, okay? So that's kind of a general look, a first look at parabolas and kind of some information about those. For class, I'd like you to answer some general questions. So I'm going to set this up a little bit for you. We're going to find out how do we find the vertex of a parabola if all we know is the roots. And we're going to use this example. For example, if the graph of a parabola is this equation, and we have roots 2 and 4, that would look something like this. So we have roots 1, 2, 3, 4, 5, 6. We have a root at 2 and a root at 4. Okay, so that means our parabola looks something like this. Okay, that's not great. Okay, so it goes through at 2 and it goes through at 4. What is the vertex? Can you figure out what the vertex is from there? So we're looking for this point, and forgive me if it doesn't end up looking great on the y-axis. But if you can find the vertex, if you can try to find that, then answer this question. In general, how did you find that? If we're talking about just any roots for any equation of a parabola. So try that before class.